Dr. Neil deGrasse Tyson is a world-renowned astrophysicist and the recipient of 9 honorary doctorates and the NASA Distinguished Public Service Medal. His research interests include star formation, exploding stars, dwarf galaxies, and the structure of our Milky Way. Tyson is the first person to hold the Frederick P. Rose Directorship of the Hayden Planetarium at the American Museum of Natural History in New York. He is also visiting research scientist and lecturer at Princeton University. Please join me in giving a big USF welcome to Dr. Neil deGrasse Tyson.
How the universe? Yeah, the universe is good. The universe is good. Your Honor, allow me to clarify my statement about mayors of towns. What I told her during our little cocktail reception was that the elected office that I have the highest regard for is mayor, because it is the highest elected official that has any direct impact on your quality of life. At levels above that, they really don't. The senators don't. They don't care, or they don't even know whether your garbage got collected, all right, or whether there's a noise problem, or whether the police are responding as they should. And so then I also said that, but the position is not so high a rank that people want to kill you, you see? So it's the perfect combination of power and influence. So it's an honor to share the floor with you here. Thank you all for this invitation. I'm further honored to be the first speaker in the series, not only for this year, but ever. So this puts pressure on me. I just want you to understand. Furthermore, I am not unmindful of the pitch of these seats upon which you sit. I also happen to know that as you get along in years and you pass like 35 or 40, if you're 40 years old and up, and someone places you in a reclining chair and dims the lights, it's bedtime. That's it. All right? Now, if you're 25, you don't understand this fact. You have no clue what that fact is. Above 40, you know you're old when the prospect of getting sent to bed early is really attractive. And below a certain age, no, I want to stay awake all night. So, all right, I came to talk about astronomy, didn't I? So let me do that. Odd, from my hotel room, I looked out the balcony and there's a 10-foot alligator sunning himself this afternoon outside my balcony. I don't know if this is normal or not. You just have alligators sunning themselves. Okay. Okay. Because I was worried. I was like ready to call 911. But the alligator was just there. You know, it's like he wasn't even worried. He was not like he didn't think he belonged there. So that's why I said I should check on that first. Also, I have are we going to dim the lights so we can see the screen a little better than that, or? Okay. Okay, now you all go to sleep. You see, that's how that works. If you don't understand this symbol, there is no way I can explain it to you. So just ignore it. If you don't. Now, my laser's kind of really bright. Does anyone have a dimmer laser than this? This is just kind of bright. Was that is that okay for you guys? You're good? Okay, good. You know, talks such as these are often, particularly in lecture series, they're often just sort of loosely veiled, like commercials for someone's next book that comes out. And this talk is no exception to that. No, actually, no. I don't like book talks because you can just read the book, right? Why do I have to tell you about the book when you could read the book? So what I'd rather do when invited to give a talk is to speak about things that you can't really find anywhere. And such is what will happen today. Now, there's stuff I could talk about if asked. I'd like to have a vibrant question and answer session at the end. And I could talk about these subjects, but I won't unless asked. Like the fate of NASA's space program, the demotion of Pluto to the dirty ice ball that it always was. Don't shoot the messenger on that one. Plus, there's like a special coming on next Tuesday on Pluto. We'll talk, if you're interested, we'll tell you about it. Big Bang, dark matter, dark energy, big profound areas of ignorance in our understanding of the universe. Search for life, we found water on the moon, the multiverse, and of course the world is going to end on December 21st, 2012. So that's if you believe 50 million internet pages that tell you that. So we can talk about that later or not. But what I want to do is offer you a cosmic perspective. A cosmic perspective, I only see just the heads of you guys here. And you just see my head, right? You see more, because sometimes my legs do things, and I want to make sure that we can do that. All right. The cosmic perspective, what is that? Cosmic perspective is a way of looking at the world that is deeply informed by our place in the universe, by how we have come to understand our place in the universe. That's a cosmic perspective. And sometimes how you invest in coming to understand the universe influences, for example, the naming of things. Let's do this by example. There's something called naming rights, and we'll highlight this. Let's put this up on the board. I know some of you are having flashbacks, right now. That mysterious chart of boxes that was in the front of your chemistry class that you swore you would never see again. Well, here it is, the periodic table of the elements. Well, I can represent these elements in different ways. I have a really cool periodic table of the elements program. You get that from Geek Central, all right, special website for geek things, all things geek. I could color code these by, for example, melting point. So let's see all the elements noted by melting point. So here we are. This is kind of cool. So the redder you are, the higher is your melting point. So the high melting point group of elements are right here. If Thomas Edison had access to this software, he would have gone straight to this element as having one of the highest melting points on the entire table. And that element W is what? Tungsten. W for tungsten, of course. Duh. Of course that's tungsten. So a lot of Edison's challenges were trying to find a filament that wouldn't melt under the high current that he passed through them. And so he experimented with all manner of filaments and landed on tungsten by trial and error. If he had this table, he wouldn't need trial and error. There's actually a higher melting point object, element up here, that's carbon, the highest melting point on the entire table, kind of anomalously sitting there as the darkest red. So this is a fun table that you can arrange this way. There are other elements down here. We'll get to them in a few minutes. So here's something interesting. Let's look at elements coded by when they were discovered, okay? So these are the elements in blue that were known to the ancients. They didn't know jack about anything else on this table, okay? As far as there was earth, air, fire, and water, and then these 7 elements. That's it, all right? So there you go. And so no elements were discovered from ancient times until 1669, okay? So let's move forward in time. Now, what year are we here? So this is now 1776, so the year of the founding of America, and we've added, of the colonies, so we've added 6 more elements, all right? So when Thomas Jefferson is penning the Declaration of Independence, these are the only known elements in the universe, right here, all right? You add these other yellow ones there. And there's some familiar ones. O is oxygen, nitrogen, chlorine, zinc, nickel, cobalt, manganese, platinum, and of course hydrogen. Now, if we, let's move a little further. It's 1869, so the Civil War is over, and a lot of investment in element discovery has been going on, and we can now take the table starts taking shape as a table. That's kind of interesting. And the Russian chemist Mendeleev is organizing these elements in a way that takes us into the modern era of chemistry. So, a couple of other things here. What element is that? Uranium, of course. Uranium is named after the planet Uranus, which only a couple of years earlier had just been discovered. So as you discover elements, chemists knew that these are important things in the universe, so they wanted to give them lofty names befitting their loftiness in the universe. So if you had an object named Uranus in the universe, then you'd come, and your next element discovered would be named uranium. Next, NP, that's what? Neptunium. So we have Uranus, Neptune. Plutonium, named after Pluto. Pluto had just been discovered in 1930. Plutonium is discovered, an element is discovered 10 years later. They say, let's name it after Pluto. So, Pluto ends up with a chemical element named after it on false pretense. Each of these are like hundreds of times bigger than Pluto. There's 7 moons in the solar system bigger than Pluto. Are they on this table? No. Pluto, when it was discovered, everybody thought it was big, and so everyone was all excited, and it turned out to be really puny and icy and weird and with a messed up orbit that crossed the orbit of Neptune, and it just got no business on this table at all. But it's there. Now, let us now arrange the table by, let's put the flag of the country who discovered each element. That'd be kind of interesting, right? That'll be a bit of history. Let's check that out. Whoa. Oh, there you go. Oh, yeah. All right, let's see what happened here. Whoa. So America is going like gangbusters in the upper part of the periodic table of elements. That means we get to name them. Are you ready? Americium. We got Californium, Berkeleyum. You just get to name it. Name it after your dog if you want to, if you're that good at it. This is investments in particle physics undertaken by the American government, recognizing that if you understand the energy contained within the atom, then you can make a bomb out of that. The bomb that was tested in Trinity Point, New Mexico, was not a uranium bomb. People were pretty sure that would undergo fission without experiment. Plus, it was very hard to obtain the uranium, the fissionable uranium. Plutonium had just been discovered in 1940. 5 years later, it was in a bomb that was tested at Trinity Point, and it was tested successfully, and a few weeks later was dropped on Nagasaki. And so this effort here, we'd like to say, oh, we're Americans and we're discoverers and we like to explore new ideas in the world. This is driven by principally a military investment in the frontier of physics. Let's keep looking. Who else is heavily represented here? Great Britain. Okay? Great Britain, or the United Kingdom. There they go. 24 elements on the periodic table. 24 elements. Great Britain, let me remember. Oh, they were a world superpower. Whoa, forgot about that. Hail Britannia, Britannia rules the world. They've got 24 elements that they've discovered. Well, there seems to be a correspondent. Who else was like really powerful? Well, not Sweden. We'll get back to Sweden in a minute. Okay. Germany, France. Okay, these are world economic and military superpowers, and they're the ones discovering the frontier of the world. Well, here's something interesting over here. Helium, neon, argon, krypton, xenon, radon. These are what kinds of elements? The noble gases. Do you know why they're called noble gases? Someone said, oh, because they don't do anything. Okay, allow me to clarify. These elements have completely closed outer electronic shells so that they can't bind and make molecules with anybody else. So why does that make you noble? Well, I'll tell you why they're called noble gases. Because the Brits discovered these, and if you're British and you're the noble class, you don't interact with the underclass. So they call these the noble elements. And it reminds me of why we fought a war to get away from these folks. There was a British accent in our provost, wasn't there? Sir, where are you from?
I am from the United Kingdom.
He is from the United Kingdom. I will atone for my comments. Tomorrow I fly to London, to Gatwick, and I will be traveling to Cambridge, University of Cambridge, to give an award to Stephen Hawking. So it will be the Cosmos Award for his efforts to bring science to the public, beyond just his brilliance that he exhibits in physics. Whew, got out of that one. All right, good. So this is just kind of fun here to see the history of the world unfolding in front of you. Now, let's figure out what happened in Sweden, because what's going on there. So Sweden, oh, there was a Swede in the audience? Okay, well, it's fine. I'll only be saying nice things about Sweden. All right, so what happened in Sweden? Why do they have so many elements? Well, there's a town called Ytterby, okay? And I think the region is called Yttria. I'm not sure, but you can correct me on that. The point is, in that town, there's a cave that have these rare earth elements in that cave. And out of that cave, they discovered elements, a bunch of elements, that no one had ever known about before, new to the periodic table. So the first one, you want to name it of the town where they found it, out of respect for the municipality. So they called it Yttrium, okay, after Ytterby, Yttrium. But then they found another element. All right, now what are you going to do? Okay, so how about call that terbium? Okay, so now they use these 4 letters. Okay, all right, that was 50 years later. Now they found another element. What are you going to do there? Erbium. Okay, so now we're like down to here. Erbium. All right. Well, 4th element. What are you going to do now? There's no letters left, okay? Ytterbium. They forgot they can go back and get the whole thing going there, okay? Then they found a 5th element, and there's no other way to slice this. So they just gave up. And where is Sweden? What part of the world is it? Scandinavia. We have scandium right there. And so this is part of that effort which boosted the element count for Sweden without Sweden having to be a world-dominating power. But this bit about international investments in science, I remain intrigued by it. Before the euro was introduced as the unit of currency in Europe, each country would, of course, print their own currency. And they put who they want to on their money. That's kind of cool to see what a country values among its people. And so I made I have my own collection of currency from around the world. And here's some of it. But I want to point out a few things. This is a Polish note here, and this is Nikolai Copernicus. All right. Right up here we have, this is Croatia, and this is Nikolai Tesla, a famous physicist. This guy, I can't pronounce his name, this is Bulgaria, but he was a great compiler of scientific discoveries and an educator. This is author and aviator Anton Saint-Exupéry, and he wrote, what did he write? The Little Prince. Isn't that cute here? And I forgot who this dude is. I forgot, but I just forgot. Some Italian, Volta, sorry. This is Alessandro Volta, after whom we named the what? The Volt. Yeah, if you're good, you got stuff named after you, all right? Shocking, yes. Anytime someone goes about your joke, that meant they're admitting that it was a really good joke. We've got, this is Switzerland. We have Euler, a brilliant mathematician. Galileo, there he goes. Galileo. We have Michael Faraday. Here he is performing electricity experiments in the United Kingdom. Brilliant. There's probably $1 trillion worth of economic electrical inventions derived from his discoveries. Michael Faraday. He's the one who first passed a wire through a magnetic field and showed that a current was induced in the wire. And he showed this to his friends. It was just a little meter would tick as he did that. And they thought it was kind of cool, so he took it to Parliament, showed Parliament. And they looked, why should we care about this? And he says, okay, you don't have to care about it now, but I'm pretty sure one day you will tax it, all right? So, so this is actually how all electricity is generated today. You have a wire that's moving through a magnetic field, it induces a current, and all electricity today in the world is made by his invention. This is Louis Pasteur, and I don't know what they're doing to this dog here, but it doesn't look comfortable. This is in Banque de France. This is my man right here, Isaac Newton. Got a little telescope, he's got his orbits, his comets. Isaac Newton, I think, is the smartest guy there ever was in the history of the world. And don't argue with me on that, because you'll just lose, all right? Do you have some other favorite person who you'd like to believe is the smartest person there ever was? Feynman, Darwin, anybody else? Tyson, yeah, there you go. I was going to say which Tyson, but no, that doesn't work, really. That wouldn't play as a sentence. Isaac Newton discovered the universal law of gravitation, the laws of gravity, the laws of motion, the laws of optics, showed how it is that planets don't orbit in perfect circles, but ellipses. He had a friend who came up to him and said, Ike, why that shape and not some other shape? Because that shape comes out of his 1 over r squared gravity law. It comes out of it. But why that shape? And he said, I don't know, I'll get back to you. I'll get back to you. So he goes back home. This is his country home in Lincolnshire, far away from London, where the plague was killing people. All right? See, when you're smart, you leave the town where the plague is killing people. First evidence of the fact that he's smart. He left London, goes to Lincolnshire. He's trying to figure out why you have ellipses, a flattened circle. Comes back 2 months later, tells his friend, okay, here's why. Actually, they're sections of a cone cut in different angles, and this is inevitable from inverse square law force. And they say, well, how did you figure that out? He says, well, the math available didn't work, so I had to invent integral and differential calculus. Isaac Newton. And who did you say you wanted to be the smartest one? Oh, excuse me. After he did all that, then he turned 26. I left that out. I'm sorry. Then he turned 26. And by the way, he died a virgin, just in case you were trying to compare your life to what you can accomplish. I'm just saying. We're pretty sure of that fact. So, are there any scientists on American currency? We got Ben Franklin. Okay. Is that why he's on the currency? Is there a lightning bolt here? Is there a kite over here? Is there a key, a glowing key? Do we know that he was one of the most brilliant minds regarding electricity of the 18th century? Do we know this at all? No. So, yes, he was one of the most brilliant scientists of his day that is cleansed from our monetary memory of him. He's on our money because he's a founding father. Oh, this guy is Gauss. Okay, Gauss. And Gauss is German. By the way, if you think of like the best engineers in the world, who do you think of? German, right, of course. In America, we think of German engineers, right? We think of their cars, if something is engineered in Germany, chances are it's going to be pretty good, right? Right? Are we together on that? Okay. So, let's look a little closer at this 10 Deutschmarks from Germany. Let's zoom in. Whoa, a mathematical distribution function on the money. Okay. Of course they have the best engineers. They got equations on their money. This is the normal function, the Gaussian distribution function, one of the most fundamental representations of things in the world there ever was, named after Gauss. So I think it's pretty important that you at least recognize your scientists among you, because you recognize that they shape the world. If you don't, you'll be misled into thinking that other people shape your world. And they can in certain fundamental ways, sure. But if you do it to the exclusion of scientists, you will lose an understanding of what actually shapes the past, present, and future. Well, let's keep going. Okay, we all know this date, of course, very solemn date. I was particularly hit hard by that because I live 4 blocks from ground zero. These images are taken from outside my window of my apartment building. So I'm closer to the base of the towers than they are tall. And this is the instant the South Tower was hit. So the fuel is not yet ignited. The North Tower had already been hit, obviously. So 20, 30 minutes later, the South Tower gets hit. I don't see the plane come in because this building is blocking my view. And just to put this in context, this building is a 50-story hotel. And from this angle of view, it comes up to about the 60th or 70th story of the South Tower. So this is a split second after contact. The fuel has not yet ignited, and you get that here. So now the fuel begins to ignite, creates a deflagration wave, and then engulfs the entire upper. So the reason why I'm going through this is not to just morbid you out or anything. This is where the towers used to be standing an hour and 2 minutes earlier. So there's a big gap there. This is the Woolworth building, which curiously and ironically spent more time with the tenure of being the tallest building in the world than did the World Trade Center. So it's adjacent to it. And after the towers fell, this is my apartment building right here. And so this is the dust from the pulverized concrete. And so I say this to make a larger point, not to just dredge up bad memories. All right, shortly after this, within a week, President Bush addresses the public. And I forgot where he did. It might have been the Rose Garden or the Capitol. Somewhere he gave a speech regarding September 11th. And he said, in an attempt to distinguish we from they, he says, our God, now let's hold aside the fact that it's the same God. He didn't know this, apparently, okay? The God of Islam is the same God of the Judeo-Christian Bible, okay? Apparently he didn't know this. Okay, so he says, our God, loosely quoting biblical Genesis, he says, our God is the God who named the stars, trying to distinguish we from they. Now, this is before I was on his Rolodex, okay? Because I could have helped him out there. What he did not know is that 2/3 of all stars that have names have Arabic names. I don't think that's the point he was trying to make. Arabic names. Arabic names. Here they go. Okay, can you read those? Do that? What? Okay. Arabic names, all of these. One of my favorite of these Arabic names is one of the brightest stars in the constellation Orion, Betelgeuse. You know Betelgeuse? You've heard of, you might have seen the movie Beetlejuice, but Betelgeuse is an actual name of a star. That stands for Armpit of the Great One, by the way. So these names just go on and on and on and on and on. Okay? So you can ask the question, how is it? How is that? How does that happen? Were we just being egalitarian? So it's your turn, we'll name stuff after you? What happened? You go back 1,000 years to Islam in this 300-year period. If you buy any book on the scientific achievements of Islam, they will be talking about stuff that happened in that 300-year period. What happened in that 300-year period? Baghdad was a crossroads of intellectual curiosity. It was open to everybody to Muslims, to Jews, to Christians, to doubters, which the word atheist didn't exist back then, but doubters, they all came. Everybody was welcome. Ideas got exchanged. Something we often take for granted today in a university setting, for example. But back then, that was kind of a new concept. And what came out of that period? Algebra was invented. The word algebra and algorithm are Arabic words. Our numerals are called Arabic numerals. They didn't invent the numerals, but they were the first ones to do interesting things with them in the invention of algebra. It just didn't stop there. Mathematics, agriculture, engineering, medicine, astrolabes from that period are some of the most collected and coveted pieces of scientific art there ever was. The navigation that took place at that time. Not seagoing navigation, but navigation through the deserts, where you always had a clear sky. Huge advances took place over that period. Then came the end of the 11th century. If you read history books, they'll say, oh, well, Baghdad got sacked by marauders, and they'll give you some traditional militaristic historical account. And they will leave out the fact that this guy, Al-Ghazali, they'll leave him out because they think that history only happens because people have wars. But there's history that takes place for other reasons that sometimes are more subtle. Al-Ghazali was a scholar of the Quran. And before he came around, everyone was just reading the Quran according to their own interpretations. Islam was not yet a coherent, organized set of rules of conduct and behavior for the entire community. So he comes along, he's an academic scholar, an interpreter of the Quran, and he gains social power and then ultimately political power and religious power with his interpretation of the Quran. And he reads the Quran and judges that, according to Allah, to manipulate numbers is the work of the devil. And given the influence he had at the time, that was the end of it. Here is a culture that invented algebra, that gave meaning to the numeral 0, which didn't exist before then in any meaningful way. All these advances in mathematics is the language of nature, the language of the universe. And if you're going to say that's the work of the devil, that's the end of your capacity to contribute on the frontier of scientific discovery. And Islam has not recovered since. Yes, the cultures has risen. There's in Spain, you have the Alhambra, gorgeous architecture. So culture has risen. There has not been a shred of science to match what happened in that 300-year period since. What's the consequence of this? Let's find out. Let's look at 100 years of the Nobel Prize, 110 years of the Nobel Prize. Okay, let's look around cultures. We happen to know the Jews, modern Jews, value education, immensely value education. Let's find out how many Jews have won the Nobel Prize in the sciences. Let's see. Of the 600 people who have won the Nobel Prize in these 4 categories, we will include economics in this list just to be kind. Okay. So, Jews have won 49 out of 28, 44, 148 out of 600. You ratio that out, you get 25%. 1/4 of all the Nobel Prizes ever won in science were won by Jews, including atheist Jews, by the way, which means they're culturally Jewish, so that the culture of learning remains with them. Let's find out how many Muslims have won the Nobel Prize. By the way, how many Jews are in the world? There's like 15 million tops out of nearly 7 billion people. 15 million Jews. How many Muslims are in the world? There's about 1.3 billion. Billion. How many Muslims have won the Nobel Prize? Anybody know? Here are the numbers. 1.5. Okay, we'll give this a full one there. 2. All right. 0.33%. This is a travesty. A travesty. That many people in the world have delivered 2 Nobel laureates in the 20th century. It's a travesty. And we can compare these numbers, ratio them. The Jews have 80 times the number of Nobel Prizes, and they're 1/80th of the population. So the impact is 6,400 times. And I lay awake at night, losing sleep, asking, how many secrets of the universe lay undiscovered because 1.3 billion people are not part of that enterprise? Had that creativity 1,000 years ago continued, they'd have every Nobel Prize. At the rate that was going, it's gone. My point is, just because you're going gangbusters at one point in time in history doesn't mean you always will. It's a fragile thing. It's not always there. It's there at some point in time because you have enlightened people, enlightened leaders, enlightened institutions that understand the value and meaning of free thought. So that no one's going to come and say, you can't think that. You can't do that. The moment people start doing that, that's the end of discovery and creativity. America in the 20th century, 20th century, just checking to see if you're awake. Anyone here over 50? Raise your hand. Over 50, good. Got my whole front row here, over 50 right here. All right. Do you remember when we all dreamt about tomorrow? We would draw things like this, Tomorrowland, okay? With like floating cars and, this is how we thought about the future when we were around back in mid-20th century. Whether or not this is the future we built, it's the future we dreamed about. And dreams carry ambitions. There are no ambitions without dreams. Does anybody think this way today? Not that I know of, not that I've seen. Anyone who here is 30 and under, raise your hand. Have you ever had this thought in your entire life? No. If you said yes, you're lying. Tell me, no, be honest. Anyone, give me a 30-year-old, raise your hand. In the back row, do you think this way?
Yeah, Michael J. Fox, Back to the Future. That's the second one. That's about it.
Okay, a Hollywood movie, okay, sure. That's fine. Movies, all right. But sure, we in our day, at your age, were like making this happen in world fairs, and we were thinking about the future as something that we would want to invent and make happen. There's a comic running around the internet now where there's a grandparent and a grandkid. The grandkid is like spunky 17, right? Saying, Grandpa, you guys had nothing when you were a kid. Look, I got my iPod and my this, and I got my computer, and you had nothing. I got everything. How do you feel about that? The kid was a little cocky, right? And the grandfather said, son, it's true. We didn't grow up with any of these marvelous things that you now enjoy. You know why? Because we were busy inventing them for you to use. Fast forward, 21st century. That's kind of where I got the correct, I should have put an ND here, right? 21st century. Let's see what's going on in the 21st century. This is a map of the world where the countries are drawn in correct size relative to their surface area, which means it's a regular map. Okay, so now, let us now distort the area of each country according to how much peer-reviewed science gets published in that country. Okay? So America remains a high producer of science content. So I'd expect America to get nice and fat. And what's this over here? What's that over there? Japan is quite an active place. Not much is going on in Africa. A lot happens in Europe. So let's see. Let us now look at countries proportioned to area. I mean, proportioned to peer-reviewed science research publications. Okay? So we're sitting fat and happy. Look at that, all right? That feels pretty good. Can't even recognize Florida. It's so fat. Look at that. Okay? Japan! Whoa! Whoa! Okay? All right, China's a little thinner than you might have thought. India's hanging in there. Another great travesty. One of the great continents of the world is essentially not a participant in this enterprise. Africa is extremely poor, and no science goes on in Africa. That's not some accidental coincidence. We've known since the Industrial Revolution that the extent to which you embrace and invest in science and technology correlates directly with your economic strength. Innovations in science and technology are the foundations of tomorrow's economies. So this map of science is also a map of economies. All right, that's fine. So we're feeling good about this. But now let's do something slightly different. Let's apportion the area not by how much science gets done, but by the change in how much science gets done between 2000 and 2010. Got that? The change. So now this is a trend line we're about to see. A trend line. Ladies and gentlemen, this is the future. If that trend line continues, America will fade to insignificance on the world stage. Notice how much bigger China got when you plot trend lines. Argentina got pretty big, okay? Not Argentina, Brazil got pretty big here, okay? Brazil. When I mention Brazil to you, what's the first thing to come to your head? Rainforest, good. Rio, what about Rio, sir? Carnival? You're lying. You're thinking of something else in Rio, aren't you? See, you hear that delay? It was like, Rio, Carnival, yeah. You're thinking beaches, aren't you? Yeah. Oh, radio telescope. He's trying to get in good with the professors here, yeah. Isn't Rio, isn't that where they invented that Tong bathing suit? Something like that? Does anyone think that's comfortable? I just don't know. When you think of Brazil, except the one guy who's just trying to impress his professor by saying there's radio telescopes there, you're not thinking science. This is a science map. So how did this get big? Did you know that Brazil has one of the largest aerospace industries in the world? Do you know that when you fly between two regional marketplaces in America, there's a near 100% chance you're flying on a plane that was designed, built, and sold from a Brazilian aerospace company? Did you know that in Brazil they invented the first jet that can fly on alcohol? That it's a community that employs 80,000 people, that Embraer, the company, has $4 billion back-ordered in airplanes right now? Brazil. We know nothing of that, do we? It's not the image we carry with us about South America, is it? This is part of the blinders that we carry with us, riding on the investments of a previous generation. Mexico is growing there. Mexico has huge resources. Just a matter of managing that properly. Europe is just, this is European Union, basically, right there. I think they just threw in Antarctica down here. I mean, just ignore ignore Antarctica. I don't think there's any. Well, there's science that goes on down there, but it's attributed to the countries that are doing the research. So what is the cost? You can say, oh, who cares? There's a cost to society. There's a cost. For example, in modern American society, you can walk into a hotel and see into the elevator and see this panel. Let's try this. So 7, 8, 9, 10, 11, 12, 14. We live in a country where people among us are afraid of a number. This is America. And then you get down to the lobby level, and then the floors below it, there's like B, SB, SBB. I'm thinking, are you afraid of negative numbers? Can I buy a vowel, please? What is SBB? Basement? Can you just go put a 0 and then go negative? I'm okay with that. Maybe you might teach some mathematics to people while they're standing in the elevator doing nothing else in their life. Wait a minute, here's a museum, an art museum, history museum. What floor is that? -1. What word is that? Deutsches translates from German to mean what? Germany, thank you. This museum is in Germany. Germany, all right? So they're cool with their negative numbers because they have equations on their money. Come back to America, I can buy this book. I bought this book. I read this book. I have not been abducted by aliens, so it works. It's got advice like, avoid dark roads at night in your car. I think there are other good reasons to avoid that, regardless of whether an alien is interested in you for having done so. But this is going on in our country. Let's do a little more here. This is the Daily News a few years ago. It heard that Mars would be closer than it had ever been in 60,000 years to Earth. And that's a news story that's now I call the Mars virus, because it shows up every year without a year associated with it. But they're saying Mars near, this is a true statement, all right? But if you're not scientifically literate, then you don't understand how to interpret that. I will now tell you how to interpret Mars being nearer to Earth than it's been in 60,000 years. Okay, what direction is this? Does anybody know? That's south? South? This is south? East? Okay, let's pretend it's east, okay, for the moment. Okay? East. I've never been this close to Spain before. Okay? That's... The problem is the American brain, when they hear that a record is being set, they don't even ask, what kind of a record is it? Is it 1 inch closer, or is it a zillion miles closer? The brain doesn't go. A scientifically literate mind that has a proper cosmic perspective will know how to respond to that question. So you go and read this article. It says, Mars will be so close, it'll be as big as the full moon, and you need sunglasses to drive at night. Here's another one, a little more subtle. You might have seen this ad just a few weeks ago. This is Holiday Inn advertising that you work in a long, hard day, and you come back to your nicely, meticulously made up hotel room, and you step into the bed, and the bed is what? Cold. So, there are employees who will get in the bed ahead of you to warm your bed for you. And so this was their official Holiday Inn photo that shows a man and a woman warming the bed for you. Now, of course, they can't touch you because that'd be just, that's That's a different service, all right? My point is here, because they can't touch you, and because they're wrapped in cuddly, warm clothing, it means their body heat does not escape this, okay? Clothing is warm because your heat does not escape. That's why it's warm. So you put this on and get in the bed is just as cold as before they went in. That's simple physics 101. But they built a whole ad campaign around this. Here's an ad from Bayer. Is there any Bayer plants nearby? Good, thank you. Okay, so Bayer. They had a campaign where their scientists and engineers would go into the schools and they would be showing off the fact that they have a lot of scientists and engineers, and that's great. Go into the schools, help out your thing. This is an ad, an actual ad, and so to go help out sort of problem kids in school. Now, hold aside the point that their definition of problem children is a black kid and a woman, okay? Let's, how about like the white guy with the tattoos that just got off the motorcycle? Where is he, all right? Put him in here too, all right? But, so listen to what they say. You're on. Try to get them interested in why lighter things fall faster than heavier things. There is no universe in which that happens. So, someone composed the sentence, it got typeset, it got put into an ad, it got reviewed, and no one caught that error. That's what happens when you don't breed the scientific literacy that you take for granted that a previous generation had put in. They finally did fix this. Here's the fixed ad. Try to get them interested in why lighter things fall as fast as heavier things. That's the Galilean experiment. So they finally did fix it. But there's more. How about math? It's not just science here, it's math. Let's see if we can try that. There we go. Change my, oh, thank you. Change my views 360 degrees. If that member of Congress had been a snowboarder, he would understand his angles there. What other, half the schools in the district are below average, complained the newspaper. That's kind of what average is, isn't it? Last I checked, about half is going to end up below the average. So that's not what he meant, the journalist. The journalist meant half are below standards or below grade level. But this was a mathematically illiterate journalist, not knowing that this sentence makes no sense. What else do we have here? Here's a good. 80% of airplane crash survivors had studied the locations of the exit doors on takeoff. That's a pretty good, you read that, you say, I'm going to study where the exit doors were next time I get on the airplane, because I want to be in that 80%. Here's the problem. Just suppose, that 100% of the dead people had studied the locations of the exit doors on takeoff. You wouldn't know because they're dead. So this is a one-sided statistic that is meaningless to you, and you cannot make a rational judgment of behavior based on this information. And here's another one. Does Florida have a state lottery? Yeah, of course, everybody's got it. State lottery, it's often said that it's a tax on the poor, the lottery. You bet money and there's like a 1,000,000 to 1 chance you're going to... It's not a tax on the poor. No. They say that because if you have lower income, that same dollar is a bigger percent of your budget than it would be for a rich person. It's not a tax on the poor. It's a tax on all those people who never did well in mathematics. That's what that is. Now, physicists know better. All right? I want everybody to have brain wiring that exists within a physicist. The American Physical Society once had their annual meeting in Las Vegas. Las Vegas. All right, so what do we have? So we've never been back since then. we're in like Tougaloo, you know, we're somewhere else, we're not in Vegas. So what else is going on today? What's the consequence of this? That we've kind of here in America, where we rode high on our science and technology, discovering elements, discovering computing was a 20th century discovery. How about today? What's going on today in America? You know what happens today in America? Our levees break. This tragedy, this American tragedy, is often recounted as Katrina. No, no. Do you realize that when Katrina hit landfall, it dropped to category 3? It passed over the city, went out the other side, and people were just sweeping up the streets, picking up some downed branches. Then the levees broke. This was not a Katrina problem. This is faulty engineering problem. Put the blame where it belongs, otherwise you won't know how to solve the problem. It's an engineering problem. Blame that on nature. Keep going. This is New York City. A steam pipe blows up. What, we can't move steam in a pipe? I thought we figured that one out. Didn't Fulton figure that one out 250 years ago? We had a bridge collapse? This is not even a big river. This is a street. What is this? I don't even know what this is. There's like rowboats in it. This is nothing. And you got a bridge collapsed? These aren't just idle spectacles. People die in these things. We've got Roman aqueducts still standing that were built 2,000 years ago throughout Europe. It looked just like that, and our bridges can't. What is this? Trains collide? Train? Okay, a train goes this way on a track, another goes this way, and they collide. What year is it? 2008? I thought they figured that out 200 years ago. A crane collapsed in New York, another one, people died. A crane collapsed into a building, someone in the top floor of that died. What else you have? You have hurricanes, okay? Hurricanes. Now, this is one of my favorite pictures because everyone is like hightailing out of town. Hurricane forming in the Gulf. Duh! I think we figured that one out, don't you? This one is the one that took out the dinosaurs right here. I once showed this and someone in the audience said, "Is that an actual photograph?" And I said, so at that point I was done. I was like, okay. I said, yep, the pterodactyl had a digital camera, snapped the picture, we got the fossilized chip out of the camera, and it's still... We got an asteroid headed our way. It's called Apophis, named for the Egyptian god of darkness and evil. We didn't name that before we discovered it was going to hit Earth. We named it that way afterwards. If it didn't have an orbit that was going to intersect Earth, we would have named it something else, like Bambi or something, something not threatening. If we have time, I don't want to spend too much time on Apophis, but it's headed our way and it could bring the end to the west coast of the United States. But if we have time, we'll go over some more details on that if you want. So what I want to do, I'm going to leave you, I have like 10 more slides, but they'll go quickly. And I'm going to say sit back in your chair because I want you to sort of feel what I'm about to tell you. Because I want to leave your brain in a new quantum state by the time you're done. This is the number one written 3 ways. All right? As a word, in exponential scientific notation, and just as a numeral. So this 0 here, 10 to the 0 power, tells you how many zeros follow the numeral 1 when writing it. So there are no zeros here, so 10 to the 0th power is 1. All right? This is a number that requires no introduction. Go up by a factor of 1,000, you get 1,000. 10 to the 3rd power, 3 zeros. Metric prefix is kilo. By the way, drug dealers were metric long before the rest of us were. Something to learn from drug dealers. Thousands, many towns have populations in the thousands. Go Go up by another factor of 1,000, you get to 1,000,000. Remember when computer power was measured in mega? Long ago, at least 8 years ago. Well, that was so 10 to the 6th power is 1,000,000. My hometown has 8 of these running around in it. That's 1,000,000, quite familiar. Go up by another factor of 1,000, you get to what number? Billion. Now we all should say this next word together. Say, pull your chin out, and then on 3 we'll say billion together. Ready? 1, 2, 3. Billion. Yeah, isn't that nice? Billion. One of my favorite numbers, billion. Billion. There's 6.5 of these running around the world. We have more billionaires in the world now than ever before. There's giga. We're up to terabytes now and teraflops and things, but giga is kind of where we are now in computer strength and storage capacity. Billion. Bill Gates, his net worth is about 50 billion. Do you know how much that is? You don't know how much that is. I'm going to tell you. $50 billion. If you had $50 billion. So I've thought about this. I walk down this, I have a job. I own a home. Okay? So that sets my interest level in money I might see on the street. Okay? So I'm employed, I'm stably employed, and I own a home. I'm walking down the street. If I see a penny, I'm not picking up the penny. If I see a nickel, I'm not picking up the nickel. If I see a dime and I'm not in a hurry, I'm picking up the dime. If I'm in a hurry, I'm going past the dime. Whether or not I'm in a hurry, if I see a quarter, I'm bending down to pick up the quarter, okay? Because that's good for parking meters and laundry and all kinds of things. So my transition between when it's worthwhile to bend down and pick something up, part of it has to do with age because you don't know if you'll make it back up. But it's between a dime and a quarter. So then I ratioed that to sort of the value of everything I own, and I said, what would the corresponding amount of money on the street be to Bill Gates, who's worth $50 billion? $45,000, okay? 45,000. So if he's walking down the street and there's a wad of cash, 45,000, he said, no, I'm too busy, let someone else get that. That's how wealthy a 50 billionaire is. You want to count to 1 billion? No, good. That's a good idea. No, because it would take you 31 years, 259 days, 1 hour, 46 minutes, and 40 seconds. But you have to account for the leap days, so you subtract the leap days, and then you have to subtract the leap seconds. So that's how long it would take you to count to 1 billion if you counted one number per second. Well, this is kind of interesting because this means if you are 31, in your 31st year, you will live your billionth second. And when I lived my billionth second, I celebrated with a really teeny bottle of champagne when that second passed by. Much more interesting to me than my 30th birthday. I have nothing to say about 10 billion. This was Bill Gates' wealth right there. Okay, so I threw Ben in there. There's Ben. One day I'm going to put a lightning bolt in here. Look, they got other junk they stamp on it. Okay, so what comes up? What comes? Let's go to 100 billion. 100 billion. So it's 100 times 10 to the 9th power. So I got 9 plus these 2 zeros on it. There they go. 100 billion. McDonald's has sold this many hamburgers. Actually, they sold way more than this, but they lost count at 100 billion. And what do they say, the ones that lost count? Billions and billions, of course. So if you had 100, well, before we get to McDonald's, did you know that in 1 linear centimeter of your lower colon lives and works 100 billion bacteria? In 1 centimeter of your lower colon. And this number is greater than the total number of all people who have ever been born. Yet we tell ourselves that we're in charge of the world. When in fact we're just hosts for bacteria. We're just nice, dark, warm anaerobic fecal matter for bacteria. 100 billion, so let's get McDonald's back in there. This was like kind of a Y2K problem for their sign, because they kept upping the number. Now there's no room to put 100 here. So this one just got, I took this like a few weeks ago. So this one they just left it at 99, said forget it, we're not changing this again. So 100 billion McDonald's hamburger, you could, if you go end to end, you can go around the earth with this many hamburgers. In fact, you can do that 52 times. And with what's left over, after you've been around the earth 52 times, you can stack them, because you're bored going around the earth. And then, how high stack could you make after you've been around the earth 52 times? A stack that can reach the moon and back with your 100 billion McDonald's hamburger, which is distressing news to cows. A trillion, 12 zeros. This painting was done a trillion seconds ago. If it takes you 31 years to count to a billion, and a trillion is 1,000 times bigger, how long will it take you to count to a trillion? Louder, please. 31,000 years. So yeah, so do not try that at home. You should have better things to do than counting to a trillion. Go up by another factor of 1,000, what do you get? We had billion, trillion, quadrillion. Quadrillion. This has nothing to do with the animal people. This is just a metric prefix. Quadrillion. A quadrillion is 100 quadrillion. That's about the total number of sounds and words ever uttered by all humans who have ever lived. Now you might ask, how do you know that? But you didn't, so I won't go there. Next, ten to the 18th power. So we had billion, trillion, quadrillion, quintillion. 18 zeros. That's about how many grains of sand there are on an average beach. 10 times as many grains of sand as sounds and words ever uttered by all humans who have ever lived. Go up by a factor of 1,000 again. One sextillion. Ladies and gentlemen, this is the number of stars in the observable universe. That number is bigger than everything we just talked about. Stars in the observable universe. Stars with multiple planets orbiting around them. That's the scale of the cosmos we're talking about here. That's just numbers. How about what the stuff is made of? Let's pull out for a minute and ask, what is it made of? What's the universe made of? The number one ingredient in the universe is hydrogen. Number two is helium. Number three is oxygen. By rank order of number of atoms. Number four, carbon. Number five, nitrogen. And number six, perhaps the most important element of them all, other. Okay, so now, how about life on Earth? What are we made of? The biologists tell us what's the number one molecule in the body? Molecule in the body? Water, thank you. What's the chemical symbol for water? H2O. The number one atom in the human body is hydrogen, present in the water molecule within us. What's the next element? You know, it's not helium. It's not, so I have to put an X through this. How come it's not helium? It's a noble gas, exactly. Your body couldn't interact with it even if you wanted to. You could inhale it and then sound like Mickey Mouse, and it's harmless because it can't interact with you chemically, unless that's all you breathe. At some point you need some oxygen in you. So cross this out. So what's the next most abundant element in the human body? Oxygen, because it was attached to the hydrogen in the water molecule. So we got hydrogen right across, Oxygen. The next most abundant element in life on Earth. Carbon. We are carbon-based life. Carbon is the most fertile chemical element there ever was. You can make more molecules out of carbon than all other atoms combined. If there was an element upon which you wanted to base complex chemistry, that's the element to choose. And the most complex chemistry we know, we call life. What's next? Nitrogen. And next, class? Other. Thank you. We are one for one the same ingredients in the universe. And only then you learn that where do these ingredients come from? Stars that manufactured them in their core, exploded. We see these explosions every day across the universe and enriching the galaxy with the fundamental ingredients of life itself. This plays out every day across the galaxy. We are not only small in time and space, we're made of the most common stuff there is. This is a message in one of our early space shows at the Hayden Planetarium. Shortly after we opened, we're on our 10th anniversary of our new planetarium. I got a letter from a professor of psychology, University of Pennsylvania. You know what he wanted? He wanted to come, he heard about the space show, came and saw it. He said, I'm assistant professor of psychology, university. I'm writing because I want to conduct a research project in collaboration with you. My research focuses on the psychological experiences with feelings of insignificance. So I said, damn, bummer of a job there. How's that? All right. I recently saw the space show at the planetarium, and needless to say, it was the most dramatic elicitor of feelings of smallness and insignificance that I have yet encountered. I'd be grateful if we can conduct a simple questionnaire survey. He's expecting people to come into the show happy and then need therapy at the end of the show. I have 4 slides left, so we're almost done. Thanks for your patience here. I submit to you that if that's how you feel upon learning our place in the universe, then the problem is not that the universe made you feel small, is that you started out with an ego too large. You started out thinking you were important, thinking there was something special about you beyond anybody else, beyond other humans, beyond other life forms, beyond other planets. You went in there with a puffed view of who and what you are in the universe, and this then alerted you of your place within it. Now, if you go in there with the right kind of ego, that's a value judgment I'm placing it. The right ego in this case would be, yes, I am small in this universe, but we have a human mind that actually is working to figure this out. So that when I look up at night, I see the universe. I see the universe. Can we dim the lights completely, please? Thank you. I look up at night, we see the universe. By the way, this is not the universe. This is a small patch of sky looking towards the center of our own Milky Way galaxy. This is not even looking outside to the rest of the universe. And there are countless stars just in this patch of the sky. We look out in the sky. But let's step out of our galaxy. This is a twin of ours, a near twin, the Andromeda galaxy. All these stars are on our nose within our own galaxy. We're looking through them out to this object, itself an entire other galaxy containing 400 billion stars. A supernova goes off, a star explodes. It enriches its regional area with the elements and the fundamental ingredients of life. This image, we've now stepped farther back away. What's remarkable about this, taken by the Hubble telescope, is that in previous images, most of the specks you saw were stars. In this image, practically everything on this image is a galaxy. There are only 4 stars in this picture. Here's one, there's one, and there's one. And there's probably one other somewhere. It'll have spikes, if you say there's one right there. Everything else in this picture is a collection of hundreds of billions of stars scattered between us and the outermost reaches of the observable universe. Unfolding in every one of these galaxies, stars are being born, they live out their lives and die. The most massive among them are those that have the privilege of manufacturing the heavy elements and exploding them into space. So, for me, the deepest, most cosmic message I can leave with you upon basking in the sheer scale of this universe is that it's not that you should feel small looking up at this. I think, in fact, you should feel large. Because looking up at this image, you know now from 20th century astrophysics, what we have discovered is that since the very fundamental ingredients that are manufactured in these galaxies are part of life itself, it's not simply that we are in this universe, the universe is in us. And that's a connectivity to the cosmos that, by my measure of ego, is in fact enlightening, enriching, dare I say even spiritually rewarding. Feeling a part of this grand unfolding drama, this epic quest to understand the cosmos, brings about a sense of journey, a sense of participation, a sense of wonderment. And it is those feelings and those thoughts that I leave you with tonight as I share with you our cosmic perspective. Thank you for your time. Thank you. Thank you. Thank you. I think I went a little long. I'm sorry, but like, I might have messed up your evening plans or something. I don't know. But I want to take just a couple of questions if we could. 10 minutes? 10 minutes. We'll do 10 minutes Q&A. Is that okay? We bring up the house lights. So you're more than just a voice in the dark. I'll be able to see you. Sure, sir, right here. Loud.
You mentioned that all electricity is created by a wire passing through a magnetic field. What about electricity produced by batteries?
What you have to do is ask, where did the battery get its power? It's from other machine where a wire got passed through a magnetic field. What's that?
It's not chemical in some
Well, no, you have to, the source of that energy, unless you have solar panels somewhere, or you figured out a way to use photosynthesis to recharge your battery. The battery got its original charge. The chemicals were put into a higher energy state for you to then draw from it through some machine that had electrical current generated by a wire passing through a magnet. Unless you want to go get solar power. There are other ways to do it. But when you get electricity out of the wall, some wire is going through a magnetic field. Yes, right here.
Hi. I recently completed a project where I interviewed several ministers from many churches and whatnot. And one thing I found very interesting.
Wait, churches and whatnot? Can we get a better sentence there, please?
There are groups of related spirituality.
Okay,
And one thing I found interesting was how they not only looked at certain texts for not just their view of reality, but morality. For example, they wouldn't just say that, oh, if we believe the Big Bang, there's no morality. And I thought, what an interesting way to look at things. And I was wondering if you had any perspective on that.
A perspective on these spiritual leaders saying that if you believe in the Big Bang, you don't have morality?
That there should not be a morality because there is no divinity doing this. I'm not trying to...
Oh, I see, because it removes a source of morality if you credit the beginning of the universe to the Big Bang instead of biblical Genesis. Okay, so morality, that would imply that people would turn to crime, for example.
That was the exact phraseology was
Okay.
do whatever they want and not care, and they'll go to the electric chair.
Right, so what they should do is look at European countries that lead the world in atheism, and they have some of the lowest crime rate in the world. That's what they just have to just... I mean, that's just, if you look at some of the Scandinavian countries, there's just hardly any crime, and nobody ever goes to church. So the presumption that if you don't believe in a spiritual deity, that you all of a sudden will turn to crime, it doesn't bear, that's an interesting hypothesis. The test has already been done. You just look around the world, right? And highly non-religious countries don't lead the world in crime. America does, okay? So that's kind of interesting. So I see crime as not really correlated with religiosity at all. I mean, I think we have to think differently about that problem. Think about how you're raised as a child and being taught what's right from wrong, regardless of the source of that principle that you're teaching. Yes?
Future of manned space program.
She raised her hand and said, future of manned spacecraft. That's a sentence, ma'am. Is there a question in there?
What are your thoughts? Are we going to go back to the moon?
What are my thoughts? There is no, well, these are not thoughts. This is just the news. We're not going back to the moon. We may be going back to Mars sometime in the unspecified future. Low Earth orbit will be handed over to private enterprise, which I think should have happened decades ago. So the problem here is, somehow here in America, we believe that NASA is just kind of some luxury agency that does some cool things when we feel like we can afford it, without recognizing that NASA is one of the greatest forces of nature there ever was on the educational pipeline to stimulate interest in science, technology, engineering, and mathematics. The fact that we were going to the moon in the 1960s ignited a flame under the next generation of scientists and engineers. People were banging down the doors to get into physics classrooms. All right? That doesn't happen today. I think the smart people who were motivated and wanted to make a difference, when NASA no longer had ambitious goals, there's no place for them to land. So they become lawyers or investment bankers or something. All right? Lawyers in the room? That's fine. Okay? I didn't say anything bad, right? I just said, so I'm just saying, so you had people who might have otherwise become scientists go into professions that were more lucrative. Okay? You don't really get rich becoming a scientist. But those who are scientists are very committed to the act of discovery. And so I submit to you that what needs to happen if we want to jumpstart America is to get NASA to have an ambitious goal, the kind of goal that we used to dream about what the future would bring, that kind of goal, and make that big and grand. And when you're a kid now, if I stand in front of 8th graders and I say, who wants to be an aerospace engineer so that you can design an airplane 10% more fuel efficient than the one your parents flew? Who's going to sign up? But if I say, who wants to be an aerospace engineer so you can design the next airplane that will fly in the rarefied atmosphere of the planet Mars, I'm getting the smartest kids in that class. I say, who wants to be a biologist? But who wants to be a biologist and dissect this frog? Or who wants to be a biologist and look for life beneath the dusky soils of the Martian terrain? I'm getting the best biologist there ever was. And so you stimulate an entire generation to become interested in what we call the STEM subjects, science, technology, engineering, and mathematics. Without NASA as that force of nature, we're all sitting there saying, oh, we just need better teachers or better schools and better this. When at the end of the day, the people who make a difference in the world are those who had ambition to make a difference. And where do you get that ambition? You get it when there's a big, bold dream standing in front of you, and not enough of the American electorate understands that, and not enough of Congress understands that. So I get asked, what launch vehicle do I think NASA should build next? I'm not even about that. I'm saying triple NASA's budget and let's get on with business. So that's how I feel. I try to keep that argument in the stratosphere and try to drag people up to it who are fighting in the trenches. Right there, yes, in the striped sweater, yes.
What kind of role do you see for science fiction?
What kind of role do I see for science fiction? I think good science fiction is good, and bad science fiction is really, really bad. All right? So, but on balance, I think the people who are fans of science fiction tend to be some of the most scientifically literate people among us and know when they're reading something bad or good. So science fiction communities is hugely organized. They have conventions and things. I was once invited. I got some award at a science fiction convention. I'd never been before. That's some scary stuff that goes on there. I'm there. You know, I said, well, I'll wear a jacket, and it's probably a casual thing, so I button-up shirt with no tie. I wear a jacket, and Klingons are walking by me, and I felt like, you know, like the government or something coming in to spy on them. And I went into the display hall, and I was lesser known back then. So they said, "Who are you?" I said, "Well, I'm getting awards. Prove it." You know, it was like, meanwhile, Spock is walking in and out, you know. Borgs are walking in and out, and they stop me at the gate. So the point is, that community is hugely informed, hugely smart, and they tend to be the people who fix everyone else's computers. So, so science fiction is a great source of entertainment. I do less reading of it than I do watching movies of it. And I only just saw Avatar like 4 days ago. I'm probably like the last person in the world. And I tweeted about Avatar. One of my tweets, I said, because you have to fit it into 140 characters, in case you didn't know. That's why they're called tweets. So I said, I just saw Avatar. Now I can make an Avatar cocktail. Okay? 3 parts The Matrix, 2 parts Aliens, and 6 parts Pocahontas. Shaken, not stirred, right? So that, which I try to comment on it. So actually I've had previous run-ins with Jim Cameron regarding the movie Titanic, because he got the sky wrong as the ship sank. It's the wrong sky. And so if you actually Google a YouTube video of me talking about this, because I don't have time to do it now, because it's a whole thing when I met him in Washington and I told him about it, and he like dissed me. And then one day he's getting an award back up in New York in my building by a third-party rental of the facility, and I was invited to have dinner with him, so we're pouring the wine, and then I come at him again saying, "You had the wrong sky!" But find it on YouTube, you'll see it. So science fiction's great. It's great. Let's go on the aisle here. Yes?
How do you feel about all of the 2012 doomsday predictions?
How do I feel about the 2012 doomsday prediction? You remembered the first slide there, didn't you? All right, so if you look that up on the internet, it'll say things like, on December 21st, 2012, the black hole in the center of the galaxy, the sun and the earth will come into perfect alignment. And that will be bad for Earth. The extra gravity will tip Earth on its axis, and it'll be end of the world as we know it. By the way, I recently bought a book. I didn't have a chance to photograph it. It would have gone next to the alien book, and it said, How to Survive 2012, okay? I have that book. So, like the Mars story, if you're scientifically literate, you don't say, "Oh my gosh, how do I protect myself from 2012? You should ask the person who tells you this, you should say, this alignment? December 21st? Ask, how often does that take place? Happens every year, December 21st. Every year. So how scary could it be in 2012 if you're not scared of it right now? If you weren't scared of it 7 weeks ago, what's your problem? So you can start probing questions. And how about the Mayans? Oh, the Mayan calendar ends on 2012. Ooh. So here we are in the 21st century. We're going to pay attention to an extinct civilization about their calendar and worry about what they say about us? For starters, okay? Second, the Mayans put the beginning of the world on August 11th, 3113 BC. 3113 BC. They were off by 14 billion years. So if the beginning of the world was off by that much, why should we think they have the end of the world correct? Not only that, apparently they did not foresee the end of their civilization either. So just bring some rational thought to this. The world is going to be here before, during, and after. What I find curious is this urge for people to always want there to be an end of the world in their lifetime. This has been going on since Jesus, okay? Everybody's saying the world is going to end in their lifetime. The last 4 times there was the Y2K, end of the world. Remember that one? We're just fine now. Then there was a planetary alignment back in the 1980s, okay? We got through that one. Whew, that was close, my gosh. So everybody's talking about the end of the world. And it seems to me that there's some people, I was at a cocktail party, and a guy came up to me asking that same question, was all concerned, and I told him this, and then he walked away dejected. It's as though he was only happy knowing that the world was going to end and was disappointed finding out it wasn't. So I think there are people that are only happy when they're sad. Okay, how about 2 more and I'll answer them in half the time. How about you on the corner there with the maroon shirt?
I am a Garrison Jones, 5th grade student, and
Is this past your bedtime yet or not? It's past my bedtime. I don't know what you're doing. Okay. Oh, by the way, if you're late for school tomorrow, I'll write you a pass, okay? You'll be good. 5th grade student, Garrison Jones, is that? Good, go for it. Now, be careful with your question, because don't make all the adults feel stupid, okay? Because that happens sometimes with 5th graders. Because you watch all the programs and you read all the books, and the rest of us just feel really stupid when you ask your question. So be gentle on us. Go.
how do you plan to influence kids in schools, in like elementary? How do you plan to influence them with science that you're teaching about to people who are like 40 years old?
Oh, okay, did you get that? How do I plan to influence kids to become interested in science if I'm spending time talking to old 40-year-old people, okay? And how old are you?
10 years old.
You're 10. See, the 40-year-olds, they're like decrepit at 40, you know. Okay. In fact, I'm going to end on this question, if I may. Okay, here's the thing. You got it backwards. You got it backwards. Kids don't need help being scientists. They're born curious about the world. They're born turning over rocks. They're born jumping into puddles. They're born catching snowflakes in their mouth. They're born testing the breaking points of things in the home. These are science experiments. My daughter, when she was still in a high chair, spilled the milk by accident, and the milk rolled along the table. And there's an eave in the table, and it hit the eave, and it dripped down, and she looked down under like that. And so we righted the cup, put more milk in it, and she accidentally did it on purpose again, and watched that happen. I did this. Now, most parents would say, don't spill the milk. I said to myself, this is an experiment in fluid dynamics in progress. She's noticing that the fluid does not jump across the gap in the table. It drops through and drips onto the ground. A similar thing happened to my son. He was playing with peas. And when you're young, you got to overcook the peas. And so one pea dropped, and it just stuck to the ground. And another one that was less cooked hit the ground and bounced. This is an experiment in elastic and inelastic collisions. You learn about this in physics class. Now, I submit to you that as adults, what we do with kids is we spend the first 2 years teaching them how to walk and talk, and the rest of their lives telling them to shut up and sit down. All right? So my point is, it's the